All right, so let's solve the quiz real quick first. Did we at least all get the programming side of this right?
Sure. Sure. The general idea.
The general idea? If you did the homework, the program part should have been trivial.
I did, but it was not in my mind at this moment in time.
But wasn't the quiz you promised?
Yeah, you said we were going to do the range of the module. And what was that? It was 0 to n-1. Yes. You said that was a quiz we were going to have.
No, I said that would be a good quiz question. So here's the solution to the quiz. Define two variables. I just named them. Shut up! Define two variables. Name 1a, set it equal to 5. Name 1b, set it equal to 7. You can make these whatever value you want. You can name the variables whatever you want. But when we add them together, we need to make sure we use whatever names we defined up here. So this should print out a 12. Go ahead.
All right, so I did mine just a little bit differently. I had a separate variable for the answer, and then I printed that.
Well, that's fine. So you did int c is equal to a plus b, and then you printed out c?
Yeah.
That's fine. Perfectly acceptable. Same answer. All right, and notice this is the Hello World program, right? With just a little bit different logic on the inside, because all programs begin and end with main. Okay? You should be able to write the shell of the Hello World program in your sleep at this point. If you're not at that point, memorize it more better. Actually, most bestest. Memorize it most bestest. Okay? Because whenever you're asked to write a Java program right now, the first thing you're going to do is you're going to sit down and you're going to spit out everything except system.out.println hello world. And then you'll fill in what your logic's going to be. Cool? All right, now homework. Homework was, oh yeah, I think I copied it, didn't I? All right, have a variable defining the number of pennies, and you can change this value. You'll hard code this value in and change it. I'll actually show you today how to read something in from the user, just because that might be a helpful thing. If you're in 325, you've actually seen it before, but it won't take long. I just won't explain why it works, just that it works. We'll talk about why it works later. So we have the number of pennies. We want to calculate dollars, quarters, dimes, nickels, and pennies. So you're converting the pennies to the most efficient denominations. And then we're going to display the answer. So, dollars is pennies divided by 100, right? And then we need to update pennies. Okay, how do we update pennies? Well, we don't need to give it a different variable name. We could just say pennies is equal to whatever pennies used to be minus what?
Dollars times 100. So you don't put int.
Dollars times 100. You only put the word int in front when you're originally defining it. When we're just using a variable, you don't have to redefine it. We're just changing the value of it. Because variables, by definition, can vary. Make sense? All right. So that's pennies. Well, this is dollars, and then we update pennies to be less pennies than it used to be. Then quarters is going to be the new value of pennies divided by 25. Right? And then we'll update pennies. I'll just type it. I need practice. Pennies minus quarters times 25. Then we're going to have int dimes. Dimers. Int dimes is equal to the new value of pennies divided by 10. Now remember, this is integer division, right? Integer division does something called truncation. And what does it mean to truncate?
Round down.
Who? Round down?
Not round down.
Oh, round down's fair. Always round down, right? It cuts everything from the decimal point over off. So it doesn't do any rounding. So round down is a little bit inaccurate, but it technically is correct-ish. Because the fact that you're rounding means there's rules associated with it. Yeah, you're wrong. So dimes is pennies divided by 10. Then we're going to update pennies again. Pennies is equal to pennies blah, blah, blah. See, my fingers are ahead of my brain. Pennies minus dimes times 10. Then we're going to say int nickels. And nickels is going to be equal to pennies divided by 5. And then we're going to say pennies is equal to pennies minus nickels times 5. And now we have the updated version of pennies, right? So now we'll do a bunch of system statements, system.out.println. Well, because I haven't shown you concatenation, we have to do this in a little bit unfortunate way. So we're going to say dollars quarters, dimes, nickels, pennies. We'll print out whatever's stored inside of our variable called dollars, whatever's stored inside of our variable called quarters, whatever's stored inside of our variable called dimes, whatever's stored in our variable called nickels, and then finally what's left over in our variable called pennies. And just so we have our starting value here, we'll say starting pennies now we have a problem. Change what pennies is. So how do I get back to my original pennies? Say this again? Well, that's fine. We'll look at some things we can change here. Okay, so right now we don't have a way of looking at our starting pennies, right?
Can't you move that to the top?
Yeah, we could. That's an interesting solution. So why don't we print out our starting pennies before we actually break pennies? Then we'll calculate all other variables and update pennies and then print everything else out. So for 1,421 pennies, starting pennies is that, dollars is 14, 0 quarters, 2 dimes, 0 nickels, 1 penny. If we change the number of pennies to 8, $0, 0 quarters, 0 dimes, 1 nickel, 3 pennies. Make sense? Go ahead.
Can we just give this to McDonald's employees now that we know that they can't run it?
Yeah, like they could run a Java program.
Well, I mean, we make it into an app and give it to them so they can do it on their phone.
Well, I'm pretty sure their register tells them what to spit back out. It doesn't?
I'm pretty.
The register, I mean, like at grocery stores and stuff, they actually have a machine that just dumps out the right coins, so you take humans out of it.
Yeah.
Why doesn't McDonald's just hire those machines?
I think they have a couple of them. So inside they do for sure.
Or why don't you just like be a modern day person and use a credit card or a debit card if you don't want to have you don't want to deal with credit debt. That way you take it completely out of their control, right? You just hand them a card, they swipe it, and the machine does the rest.
You want them touching it?
Huh? You want them touching it? Well, they are handing you your food. Well, if you go inside, you swipe it yourself, don't you?
No. Yeah.
I've been to a lot of McDonald's at least where you swipe it yourself. Maybe you got some of the old ones, you know. You would think this McDonald's down here would have plenty of money since they were running that drug operation out of there. You didn't hear about that?
No.
Last year.
Yeah, it was last year. Like,
I thought it was a joke.
no, they did like it was that one, like 2 other locations owned by the same owners. They did this huge drug and law enforcement raid. I mean, like people with like major raids going in, and apparently they had a after hours special menu. You go through the drive-through, and if you knew some of the correct code phrases, you could order off menu. All right, questions about this? All right, so let's update this a little bit just to say, if let's say we wanted to have the user enter in how many pennies, as opposed to us hard coding it here. So we're going to use something called a scanner. And I'm not going to talk too much about it right now, just know that this works for reading something in. So we're going to say scanner input is equal to a new scanner system.in. System.in is the standard input, which is our keyboard. And it's going to yell at us here saying, I don't know about scanners. So if you highlight over it, it's going to make us import something. Don't worry about that yet. We'll talk about it. So we'll just click the button. It imported something, and now it's happy again. We'll go ahead and prompt them. How many pennies? Now, interesting thing here, we've always done println. If I want to prompt them and have it stay on one line, I can say system.out.print. That just will avoid pressing enter after it. All right, so I can say how many pennies, give them a little prompt, then we'll read in the number of pennies. The number of pennies is going to be the name of my scanner variable. Notice this is the same thing as any other variable. Type, name equals value. We don't know what some of this stuff means yet because it's an object type and we haven't learned about them yet, but creating a variable in Java, in C++, in C#, in Objective-C, in C, all the same. It's always type, variable name equals value. So we're going to say input dot, what's that, next int. All right. So now we've added in the ability to prompt them for the number of pennies, and then we just do the same math as we did before. So when I run this now, it's going to sit here and ask how many pennies. So we're going to put in 241 pennies. Press enter. It's going to spit out. Starting pennies was 241. Dollars is 2. Quarters is 1. Dimes is 1. Nickels is 1. Pennies is 1. If you want to make this formatted a little bit nicer, what we can do is we can come up here and we can change all of our printlns for our prompts, for our labels, if you will, to just prints, and then do the println on the value. It'll say dollars space the number of dollars instead of dollars enter number of dollars. Just clean up the interface a little bit. So that's the difference between print and println. One presses enter, one doesn't. When we start talking about strings, we'll talk about string concatenation, where we probably would have put both of these lines on one line. But we don't know about that yet. All right. So now I'll hit play. How many pennies? 489. Starting pennies is 489. Dollars is 4. Quarters is 3. Dimes is 1. Nickels is 0. Pennies is 4. Make sense? All right, questions or comments about that? So, new thingy is scanner object reads crap in from user KK thanks. You can leave that last part off if you want. It's just filler. And that's all I can tell you about it right now because we don't know enough to fully explain the object. Now remind me, what's a Boolean expression? Any expression that boils down to a single value of true or false. Remember the cadence? It was who do we decide who's doing the humming and get a cappella. All right, so we talked about Boolean expressions last time. Any expression that boils down to a single value of true or false. We talked about the arithmetic Boolean operators, which are completely foreign symbols to us. We've never seen these before in our life. Less than or equal to, greater than or equal to, equivalent to, not to be confused with the assignment operator, which is the single equal sign, and then not equal to. We also have the logical Boolean operators. Double ampersand is an and, double vertical bar is an or, single exclamation point is a not. All right, so let's mess around with those a little bit because we're going to be building Boolean expressions because Boolean expressions become a very, 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 very important part of computer programming because we use them as a part of a lot of different things, including conditionals, asking questions, and loops, repetition. All right, so let's get rid of all this crap. It's going to get even more entertaining later on when we write like really, really complex code and I just delete it and you're like, oh, that's gold. I just get lots of entertainment out of that. What was I doing? Oh, Boolean expressions. So we're going to create a couple of variables. Int a equals 5, int b equals 7. We can print out system.out.println, and we did a little bit of this last time. A less than b, and that's going to be a true, right? 5 is less than 7. Now we have the logical Boolean operators, like an and. So ands and ors deal with kind of like real life things. If it's warm outside and it's sunny, those two things are true. Is it sunny yet? Is it still cloudy? Still cloudy. Okay, so it is warm outside right now, right? But it's not sunny. So if I say it's warm outside and it's sunny, I'm actually lying, correct? That's a false statement. Both of those things need to be true in order for the entire thing to be true. Okay, but if I say it's warm outside or it's sunny, only one side needs to be true. Right? So it could be sunny and it could be warm, but if I said right now that it's warm outside or it's sunny, we could say that I'm not actually technically lying to you. Correct? So that's the or. So or says at least one part of the Boolean expression is true. And says all parts of the Boolean expression must be true in order for it to boil down to true. Otherwise, it's false. Make sense? The not operator flips a Boolean value. So not true is false, not false is true. So what will the output of A and B be? Completely ignore the red fuzzy line. Doesn't make any sense.
5 and 7.
Yeah, 5 and 7. What do you expect the result to be? Do you? Why false? Explain to me your logic.
Well, I mean, you're comparing the two, so you're saying that it's A is the... Oh, well, there is no logic to it, actually.
5 and 7. What should the answer be? It's an error. It doesn't make any sense. What would you expect it to be? It's like, oh, I want to make ice cream, so I'm going to go for a jog. They have nothing to do with each other, right? So, this doesn't make any sense. That's why we had the numerical, the arithmetic Boolean operators for dealing stuff with numbers, but we have the logical Boolean operators for doing things with Boolean values. So I can say A less than B and B not equal to 12. What will the output of that be? A is less than B is true. B not equal to 12? Also true. So we have true and true. Both sides are true. Now, this gets back to our idea of variable resolution. When we look at this, there's a lot of crap going on in here. But the reality is, if I break this down, A less than B, first we replace the A with a 5, then we replace the B with a 7, then we say is 5 less than 7? It is, so that all boils down to true. B we replace with a 7. 12 is a literal. We don't replace it with anything. No variable to resolve. Is it true that 7 is not equal to 12? That's true. So all this junk in here at runtime ultimately boils down to this. True and true is. So at the end of the day, all this crap is just like typing the word true. But there was runtime logic involved. You know, we hard-coded a couple of numbers in here, but what if we had read in from the user? We didn't know what they were going to enter in for A and B. That make sense? Then the output of this line could be many different things, depending on what they happen to put in for A and B. That make sense? That's our Boolean logical operators. And if I want to throw a little wrench in here, I'll put the whole thing in parentheses and then put the little not operator out front. So now what we have is this. We have not true, which is what?
False.
False. That whole thing boils down to false. See how that's resolving? Very important when you're looking at lines of code and somebody says, what does this do? You actually step through and resolve it. Don't just look at it as one like big painting and just make a guess. Because sometimes things aren't what they appear to be. So there's our false statement. All right, make sense? All right, that's Boolean expressions. Any expression that boils down to a single value of true or false. Now, if we go all the way back here to, I don't know, whatever, first couple slides, how do human beings solve problems? We use memory. That's our variables, right? We use asking questions. And asking questions, that's going to be our next statement we're going to learn. Ask questions. Programming languages emulate this through something called conditionals. In C-based languages, this is specifically done through something called an if statement. There's actually another way of doing it. I typically don't cover it because nobody uses it anymore because it's stupid. It's something called a switch statement. They have uses, but it's just dumb. Don't use them. All right, but no, they exist. But we're going to look at if statements. All right, syntax for an if statement. It's the word if. All lowercase. Remember, Java's case sensitive. Followed by an opening parenthesis. Followed by a Boolean expression. What's a Boolean expression? Any expression that boils down to a single value of true or false. It's funny. It's almost like I choreograph this stuff, but totally don't. I'm just crazy. So, if, opening parenthesis, some Boolean expression, that is any expression that happens to boil down to a single value of true or false. Don't get tricked. This guy, is that a Boolean expression? It looks like there's a lot of crap there, but it does in fact boil down to a single value of true or false. Okay, I'm about to trick you. Ready to be tricked? Is that a Boolean expression?
Yes. Doesn't work that many.
Is that a Boolean expression?
Yes.
It's a single value of force.
What is this? What kind of animal is that? You see that in the wild. What would you say that is? Okay, you said variable type. Here, what kind of animal is that? It's a number. Value. What's another word for value? No. Variable boils down to a value. It's not a value itself. Literal. Who said literal? Oh, good. Star for the day. It's a free psi Raphael weapon. Apparently those are really dangerous, but it doesn't seem like they'd be that effective. You know.
I mean, if you only have 3 fingers and you punch people with them, 'cause that's kind of what Ralph.
Well, but I mean those. Oh well. So you're saying like the psi is like 3 fingers,
Well,
but they don't break as easy,
No, because Raphael only has like the 3 fingers.
right?
And he just like holds it like he punches people with it. So, I mean, it's like having brass knuckles with a knife on the end of them.
Yeah. So instead of poking them in the eyes, they're stabbing them in the eyes.
Yeah.
That makes sense.
Yeah.
But like, you got to get in real close to do that.
Yeah.
It doesn't seem like effective.
Oh no. But it's Teenage Mutant Ninja Turtles.
Right. I mean, like the modern day way of doing this is we put missiles on things and we fly them in via drone. Right. That way we're not in danger at all. What?
Really fun to watch from a blimp.
From a blimp?
Yeah, we got cameras on the blimps, and you just sit there on a little computer desk and watch them fly it in.
What blimps are we talking about?
Yeah, it's like blimps over some of our bases.
You just fly blimps?
Yeah, just a little blimp. Got a bunch of cameras and shit on it.
It doesn't seem like that would be that agile.
No, it's really not. No, we just have the blimp up top, and then you see the drone fly out, and you can watch what the drone does.
But doesn't the drone going like far away? I don't know that we want to be firing crap like right in the vicinity.
No, that's why we got a blimp way up high with really good cameras. We can see 50 miles with a camera.
Why are the drones only going 50 miles? I'm thinking about putting an unmanned boat, shipping it overseas with a bunch of drones on it. And then we're like sitting in like DC. And it's like a video game, right?
It's like Hot Pockets.
So I don't know. But somebody told me this is a literal, right? How did we get to talk about psi? Oh, that was your reward. Your reward. That's how we segued to that. Okay. So this guy is a literal. What's this guy? That guy's a literal. Is that a Boolean expression?
Well, press play.
What's the value of this?
True.
It's a literal whose value is already true. No resolution needed, right? What does that boil down to?
True.
True. What's a Boolean expression?
True or false.
Any expression that boils down to a single value of true or false. Is that a Boolean expression? Confidence. Is that a Boolean expression?
Yeah.
It is a Boolean expression. There's my value true. Okay, so Boolean expressions can be that simple. It's a wasted Boolean expression. Because if you said, if true, you kind of just wasted your time asking the question. Right? Because you already knew the answer. But technically, that is a Boolean expression. So Boolean expressions can come in a lot of different forms, so don't necessarily judge a book by its cover. That's a Boolean expression just as that's a Boolean expression. Is that a Boolean expression? Well, I thought you said 5's a literal, and true is a literal.
It's not true or false.
Different kind of literal, right? So this is a literal, just like the value true is a literal. Literals are anything that's a hard-coded value. Boolean expressions are only things that boil down to the specific hard-coded values of true or false. All right. So, asking questions. The word if, all lowercase, followed by an opening parenthesis, followed by a Boolean expression, followed by a closing parenthesis, followed by an opening curly brace. 0 or more statements, followed by a closing curly brace. And we only execute. So here, let's replace 0 or more statements with just the word body. Only execute the body which actually seems kind of morbid. Okay. Only execute the body if the Boolean expression is true.
You can pretty much put a whole or program inside the body.
We're going to do it here. We're going to say, so we'll just give ourselves a single variable, a. I'm going to say, if a is less than 10, system.out.println cowabunga? Is that how you spell it?
I think it should be go to bunga.
Cowabunga. Cowabunga is what the turtles say.
Yes, that.
That's right. You checked it? Googled it?
I mean, I just know it.
You just know. You didn't get your whole quiz right, did you?
I messed up my system.out.
Oh, but you got the turtles right.
Yep.
Oh, that's all that's important.
Sweet.
All right, so that's what turtles say. So as long as a is less than 10, we're going to print out cowabunga. Cowabunga. Because a is 5. Is 5 less than 10? It is. But what if I put in a is 50? What's the output of this program going to be?
No cowabunga.
Nada. There is my program. Nothing to display. But don't we sometimes want to say something else? Like instead of cowabunga, maybe we say boo. With a little sad face. Pointy nose, sad face. Because dude should wear glasses. There we go. But let's go ahead and switch it back to 5. Now what's going to print out?
Cowabunga and boo.
Ah, cowabunga and boo. This guy always happens. He's not contained within the if statement. Here's the question we're asking. Only this stuff, the stuff contained within the opening and closing curly brace of the if statement. So notice a new use for the opening and closing curly braces. Only the stuff contained within the opening and closing curly brace of the if statement actually get executed based on whether or not this is true or false. Stuff that's outside of the if statement happens regardless, unless it's inside of another if statement or something like that. But, you know, this guy is not does not conditionally happen based on this Boolean expression. But what if we want it to happen based on it? So what if we want this to happen if a is less than 10, but we want this to happen otherwise?
Just basically the same thing.
Well, we can wrap it with another if. We can say if a is greater than or equal to 10, wouldn't that be the inverse of a less than 10? So ask two separate questions. So we ask one question here, then we ask another question here. Run this. There's our cowabunga. Change it to 50. There's our boo, but we don't get both. But isn't this kind of a waste of time? Go ahead.
You use like a thing to say else.
Else. Yep. So, and we'll look at the syntax here in a second. But this is a waste of time, isn't it? We know that a will be greater than or equal to 10 if a was not less than 10. Both of these can't be false, correct? That's impossible. We ask the question, is a less than 10? And the answer is false. No, it's not. That means it must be greater than or equal to 10. So this is really a waste of time asking this question. But because these two are separate questions that don't have knowledge of each other, we had to ask it twice. But we have an optional version of the if statement. If Boolean expression, opening curly brace, we'll call this the true body. Little Lutheranism tossed in there. That's a point for Christian worldview, I think, right? It's really hard to rack those up in a computer science class. You got to take them where I can get them. Biblical integration. That sounds creepy.
That's what they call it.
I don't think that's true. No, I think like in the, let's just say integration of a Christian worldview in the classroom. What was I doing? Oh, optionally, else, followed by an opening curly brace. Call this the false body, followed by a closing curly brace. And again, I'm writing all this on one line just for the sake of slides. I showed you last time you could technically put your entire Java program in one line, but don't do that. Okay? So we can go and we can throw that in an else. So if this is true, execute the true body. Otherwise, execute the false body. It will never do both. Make sense? Okay. Now I've actually partially lied to you here. Okay. But the reality is, I don't want to ever catch you not using opening and closing curly braces with if statements or else statements. These guys are technically not required. Technically. Because officially, the official syntax is this. Now, let me go on to another slide. Official if statement syntax would be if opening parenthesis Boolean expression followed by true statement. Or if Boolean expression followed by true statement, else false statement. So all that has to follow an if is a single statement. So I can remove all these curly braces here. I'm going to leave the spacing kind of creepy for right now. We'll fix it up here in a second. And we will have the exact same output for this program. There's boo when it was 50. And there's cowabunga when it was 5. Exact same output. But Ruh-roh, Shaggy. Scooby-Doo reference? Oh, we got that one? Not the turtles.
I was thinking Scooby and Shaggy.
Okay, what color bandana did Scooby-Doo wear? What was his weapon? He was Scooby Snacks. What's up? Shaggy's dead? Oh. The guy who did the voice. What was I talking about? Oh, so what would the output of this be?
Scooby and Shaggy at McDonald's.
What?
It'll be Cowabunga or Boo and then Ruh-roh, Shaggy.
Okay, so A is 5. Is 5 less than 10? Yes, so it's going to print out Cowabunga and then Ruh-roh, Shaggy. But with our indenting, it looks like this stuff belongs to the else. It looks like this stuff belongs to the if. Here, we'll even make it look a little more obvious. Boom. We've indented. Everything looks completely legit. What if I change this to 50? Boo and Ruh-roh, Shaggy. So no matter what I do here, Ruh-roh, Shaggy shows up. right? Okay, why is that? It's because technically an if statement will execute a single statement following it, just as an else will execute a single statement following it. We just happen to have something called a block statement. That is a collection of statements. That make sense? Open and closing curly brace gives us the ability to have a collection of statements as a single statement. So a block statement is a statement, but it happens to be a statement that is a collection of statements. It is never, ever, 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 ever wrong to use an open and closing curly brace. You will never get into a situation where like, oh, I shouldn't have used them as it relates to the if statements. I need to clarify that because one of the main errors that beginning programmers run into is curly brace diarrhea. You just have curly braces all over the place in your programs. Like, get to the end of it, well, I mean, a couple more of those in there. And you wonder why it doesn't work. Okay? That's the argument I say whenever you have something that should have an opening and closing curly brace, you write the opening one and immediately write the closing one. Now you don't need to worry about matching them up. They're matched. Make sense? Okay, so, and there is no pill that cures curly brace diarrhea. Only practice. It's like a meditation thing, I guess. What's up?
Can you get food proof for it?
What was I talking about? Oh. So now, by wrapping these guys in its own block statement, now the retro shaggy only goes with the else. So there's the same, seemingly the same output for when it's 50, but when we switch it back to 5, we will only get cowabunga. That make sense? All right, so as we saw, technically the curly braces are not needed. I would strongly recommend you always put them in there. Imagine you have 10,000 lines of code and you've decided you want to, oh, because I'm so brilliant, I'm just not going to use curly braces here because I know I don't have to. Okay, but because your indenting, was so good because you're brilliant, right? Or as Doctor Who would say, I'm clever. Clever. I like how in Doctor Who, everybody from every planet's British.
Of course.
Yeah, makes sense. What was I talking about? Oh, so if you look at this, it looks nice and clean. We would assume these things go together, but if this is mixed in 10,000 lines of code, this could be a very easy bug to overlook in your program because this line will always happen. And if it's a print statement, you probably can find it pretty easily. But what if it's just a math statement? What if you have a variable that's super important, var, and we're going to say that's now equal to -1. Probably have to define it somewhere, but you get the point. So if we only want to set it to -1 inside this else, but now all of a sudden we're screwing up our math by setting it to -1 always, that might be a hard bug to track down. Make sense? Okay, so you're never wrong using opening and closing curly braces. So I see no reason why you shouldn't just always use opening and closing curly braces. It's good for our confidence to have less errors, correct? Because one thing you're going to run into is as soon as we start writing more complex programs, and you probably ran into this in this small little baby assignment we had for today. How many of you wrote it right off the bat and had 0 errors? There might have been a couple of you, but generally speaking, you had at least a couple. Any of you had more than 10 errors?
At one time.
Yeah, just random, like you forgot one stupid thing. You threw a curly brace there. You threw a semicolon at the end of a line that you weren't supposed to have it, and basically you thought everything after that was just horrific. Just error in every line. So one of the things you're going to be dealing with for a while is you're going to have a lot of errors in your code, and it might all stem from one little problem. So any strategies you can take to cut down your error proneness will be advantageous. So always use the curly braces. Make sense? All right. So that is how we do conditionals, asking questions. Repetition. Oh, I think I spelled that right. Woot.
Yeah.
I tell you what, when you do a PhD, you have to write a book. Man, if I didn't have my wife to proofread that, my advisor would have just thought I was like a kindergartner right now. See, programming I'm pretty solid at, but oh my gosh, writing like English papers and stuff. When in doubt, add commas, right? See, I'm warning you not to have diarrhea of curly braces. I still have diarrhea of commas. It's a sickness.
Can I buy your book?
Yeah, well, it's at the Library of Congress.
Probably not Amazon.
Yeah, you can probably buy it. And I don't think it's on Amazon. You can buy it from the Library of Congress. It's a exhilarating read.
What's it about?
Well, actually, you gamers out there will be. It's the title for it. Here, I'll just type it in here. Then I'll remove it. It's a Java-based implementation for the creation and maintenance of collaborative virtual environments. That sounds like all legit and stuff, right?
Yeah.
Yeah, no, it's a programming language specifically built for creating video games like EverQuest. Collaborative virtual environment. Haha. So I wrote a video game.
You would have been really screwed if she hadn't proofread it. Your title would have been spelled wrong.
Seriously.
Yeah.
Seriously. I mean, that sounds like a legit title, doesn't it? Yeah, all these research degrees, that's all it is making it sound like it's just as technically amazing as possible. So it was like a 600-page book, and like 300 pages of it was code. It was epic. Yeah, but unfortunately, it was just too theoretical. The Unreal Engine didn't buy it from me. I don't get it. No, not enough graphic stuff in it. What was I talking about? Oh, repetition. So repetition is doing things more than once. We have, well, this is done in programming languages, emulated in programming languages through something called loops. Okay, in Java, we have 3 types of loops. We have while loops. We have for loops. And we have do-while loops. Okay, we're going to talk about each of them here on this slide and then look at each of them individually. Each loop, well, here I'll do a blanket statement. Any problem that can be solved with loops could be solved with any of these 3 loops, with maybe the addition of some if statements. These three loops don't necessarily act identically. Okay, but you can solve any problem with any of the 3 loops. A while loop, but each loop lends itself to a certain type of problem. So while loops lend themselves to problems where we do not know how many times we need to loop. Example of that, press any key to continue. How long will it be until they press a key? Could be a second, could be a week, could be never. Have they pressed the key yet? No. 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 Have they pressed the key? Just keep going. How long are they going to do this? That's the type of problem while loops lend themselves to. For loops lend themselves to counting problems. Or maybe a better way of saying problems where we do know how many times we need to loop. Now, both while loops and for loops are what are called pre-check. Pre-check loop. That means we check the Boolean expression before we execute the body of the loop even the first time. A do-while loop is a post-check loop, which means we will execute the body of the loop at least once. So this lends, these lend themselves to problems where we need to do something at least one time. Now, in terms of pecking orders, you will likely use for loops the most often, followed by while loops. And then you will rarely use do while loops. But what's funny is every single day, every one of us runs into a problem that would need to be solved using, well, would likely be solved using a do while loop. How many of you checked your email today? Or logged into some website somewhere? Authentication. You have to provide your username and password at least one time. If you screwed it up, they're going to ask for it again, right? Now, most of our websites, they put it in there for you automatically, right? And they automatically log you in, but you know what's happening. That authentication is still happening in the background. Okay? So authentication would be a very, very, very good example for something that a do-while loop would lend itself to. So if at some point somebody asks you in a quiz, what kinds of problems does each type of loop lend themselves to? Or what are the 3 types of loops and what problems do they lend themselves to? That kind of sounds like a quizzy question, right? This slide would be very helpful. While loops lend themselves, they're pre-check loops, lend themselves to problems we do not know how many times we need to spin, how many times we need to loop. For loops, also pre-check loops, so very similar problem-solving mentality to while loops. But they lend themselves to problems of counting. We do know how many times we're going to spin, which just happens to be a very, 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 very common occurrence in computer programming. Let's do something 10,000 times. Well, rather than writing 10,000 lines, let's just do it 10,000 times. Okay? While loops are do-while loops rather, are post-check loops where we have to do something at least once.
So does it always go back to the loop, or do you
Yep.
have to like?
I'm about to talk about it.
Oh.
We'll see how they work. So that's your 2,000-foot view. So let's look at while loops. While loop, as I said, it's a pre-check loop. Syntax is the word while, all lowercase, followed by an opening parenthesis, followed by a Boolean expression. What's a Boolean expression? Any expression that boils down to a single value of true or false. Who is me? Somebody else is doing it too. Oh, no, I am doing it. So is anybody else humming along with me for extra credit? No, you had to have already committed. All right. So while, Boolean expression, opening curly brace, loop, oh, here, we'll call this true, well, here, I'll write it the official way. True expression, just like if statements, technically opening and closing curly braces are not needed. But it will never be incorrect to use opening and closing curly braces. Even if you're only going to have one statement in there, go ahead and put it in opening and closing curly braces. Your code will look more structured. Okay? So I'll go ahead and throw the curly braces in here as part of the syntax. Pre-check says we are going to ask this question first before we execute the body of the loop even the very first time. So while loops execute 0 or more times because this statement might be false right off the bat. All right. Now, if this statement is true, then we're going to execute the body of the loop. Then we're going to spin back up and ask the question again. If it's still true, execute the body again, spin back up, ask if it's true again. So we do need to be careful about infinite loops. There probably should be something that happens within this loop that potentially or eventually makes this guy false. Make sense? So as an example, we're going to write a while loop. We're going to say while A is greater than 0, system.out.println, cowabunga, and then we'll say A is equal to A minus 1. So first time through, A starts off as 5. Is 5 greater than 0? Yes, that's a true statement. So we'll print out cowabunga, then we'll set A to be whatever it currently is minus 1. So A will become 4. Spin back up, is 4 greater than 0? Yes. Print out cowabunga, 4 becomes 3. 3 greater than 0? 2 greater than 0? 1 greater than 0? 0 greater than 0? No. So we'll fail there and fall past this to whatever comes after, and I'll just do a print done. Make sense? So we run this, and there's cowabunga 5 times, followed by done. If I change this to greater than or equal to, it'll spin 1 additional time because 0 is greater than or equal to 0. And what's really nice about this is all we changed is the number of times we're going to print this. So we're going to do 50,001 cowabungas. Boom. So there's 50,001 cowabungas, followed by done. About 500,000, 5 million. But 5 million cowabungas. I'm about to show you something interesting. So notice that this takes some time to run, right? Still running, actually. Still running, still running, still running. Takes time, right? Okay, so I'm going to go ahead and hit the, I'm going to say int count starts off at 0. Instead of printing something out there, I'm going to say count is equal to count plus 1. We're just going to count the number of times we went through there. Looped. Oh, here, we'll just print out count. So this loop is still going to go through 5,000,001 times. But now I'm counting in here instead of printing something out. Notice how fast this runs. I/O, whether it's reading, writing from a DVD, whether it's reading or writing to a computer screen, whatever it is, input, output, is very expensive. It takes time to do that. So to print 5,000,001 things to the screen is way, way slower than to do something 5,000,001 times in math. And we just saw it, right? I mean, this was, from our perspective, instantaneous. And remember, Java's slow because it's interpreted at runtime. Make sense? Okay, so now that doesn't mean that don't do I/O. Just means when you're often, and we'll see this as our programs get more and more complex, and before I introduce you to the debugger, when you have some weird bugs in your program, you might go through your program and you might put some print statements out. Just say, this is the value of this variable right here, this is the value of the variable right there. Somewhere between here and there, something bad went down. So you know that it changed here, so you can look for your error somewhere in the middle. So you'll put print statements throughout your code just to kind of make sure the values are what you think they should be at different points. Well, one thing you might notice is if you throw one inside of a loop, well, it might take a long time to run if the loop is running a lot. Now, when we saw we only went through 5 times, or even 50 times, or 500 times, that's fine. 500 times. It was basically instantaneous, right? We did see it finishing at the very end, but 500 times wasn't the end of the world. Certainly ran in a second or less. But it scales. Okay? And part of the reason for that, and you learned about this in the operating systems class, is whenever you have to do I/O, your processor gets put on hold. Something that happens is called a context switch. That's foreshadowing for another class. So it's a context switch where your processor is put on hold, and then it goes and does something else. Now, your homework assignment. Write a program that counts all of the odd numbers between 1 and 1,000,000 and displays the number of odd numbers between 1 and 1,000,000 to the screen. Should be pretty easy. Get you a little practice with loops and a little more writing code. Make sense? I'll put it up on Angel, but that's what you're going to write. Program that displays all of the odd numbers between 1 and 1,000,000 to the screen. I'm sorry, no. Program that counts the number of odd numbers between 1 and 1,000,000 and displays the number of them to the screen.
That's taking a long time.
Okay. So it should display 500,000, but you should actually do the counting. Okay?
I just have a question for the correct change homework we have.